Welcome to the channel. My name is Charles Carroll. This video is part of the PIW-CWG series, where we explore how structure, information, and persistence shape the universe, layer by layer, using careful reasoning grounded in established physics. In this episode, we revisit one of the most familiar observations in cosmology, redshift, and ask a different kind of question about it. This is episode 20, Hubble-Note, Redshift Ledger. Why cosmic expansion may function less like a force acting on galaxies, and more like a record of what the universe has already done. When we learn cosmology, expansion is often described as something the universe is doing now, space stretching, galaxies being carried apart, distances increasing over time. This description is not wrong, but it can be misleading. It frames expansion as an active process, when in many ways it behaves more like a cumulative record. Redshift does not push light. It marks what light has already experienced. Every photon we observe carries a history. Its wavelength tells us how much the universe has expanded along its path, not because something acted on it locally, but because the geometry it traveled through accumulated change. Redshift is not a force applied at emission or reception. It is a ledger entry written during transit. This distinction matters. Forces act locally. They accelerate, decelerate, deflect. Redshift does none of these in the conventional sense. A photon is not stretched at a point. Its wavelength reflects the total expansion between where it was emitted and where it is observed. Expansion leaves no local signature, only a global one. In this sense, the universe is not continuously pushing things apart. It is keeping score. The Hubble relationship, the connection between distance and redshift, can be read as a mapping between separation and accumulated expansion history. The farther light travels, the more history it integrates. Distance becomes a proxy for time spent moving through an expanding geometry. This is why the PIW-CWG framework refers to expansion as a ledger. The universe does not remember deliberately, but it does not erase consequences either. Once expansion occurs, its effects cannot be undone. Redshift records that irreversibility. Importantly, this does not deny expansion. It reframes its role. Expansion is not an agent making things happen. It is a condition that leaves traces. Like entropy, it marks which configurations are no longer accessible. A photon cannot regain its original wavelength without additional work. That cost is real. Seen this way, cosmic expansion is closer to bookkeeping than propulsion. It tells us how much geometric change has accumulated, not what is actively acting now. The universe carries that information forward, whether or not anything observes it. This perspective also clarifies confusion around energy loss. When light redshifts, it appears to lose energy, but nothing absorbs that energy locally. It is not transferred to a medium. Instead, the ledger reflects that the universe has changed in a way that makes certain energy states unreachable. The loss is not to something else. It is to history. This interpretation aligns naturally with persistence. Expansion does not reset. It accumulates. Each interval of growth adds another entry to the ledger. The present state of the universe is constrained by all previous expansion, not just current conditions. It also explains why expansion is uniform yet informative. Even if expansion is the same everywhere, the amount recorded depends on path length and duration. The universe does not need structure to record expansion. It only needs time and persistence. From this view, redshift surveys are not measuring a force field. They are reading a long-form record written into light itself. Each galaxy spectrum is a time-stamped entry, encoding how much expansion lies between us and that source. This is why redshift remains powerful even as models evolve. You can reinterpret dynamics, but the ledger remains. The universe cannot erase how much it has expanded without violating irreversibility. Cosmic expansion, then, is not best understood as something the universe is doing to matter. It is something the universe has already done and cannot undo. This was episode 20, Hubble-Note, Redshift Ledger, and why cosmic expansion functions as a record, not a force. If you made it to the end, thank you for listening carefully. These episodes are meant to slow ideas down, not speed conclusions up. Thanks for listening. Join us next episode, episode 21, Void Record Theory, and how information can persist even where matter disappears.